MEESST, the Magneto-Hydrodynamic Enhanced Entry System for Space Transportation. Atmospheric re-entry is one of the most challenging phases for any space mission, and we are working on making it safer and more cost-effective. Space is humanity's next frontier, holding the promise of great scientific progress and immense commercial gain. The first step on that journey is to solidify our presence in Earth's orbit, which is where most spacecraft are currently operating. To stay in orbit, these spacecraft need to travel at hypersonic speeds of at least 8 kilometers per second, which is over 10 times faster than a speeding bullet and over 20 times the speed of sound. Spacecraft arriving from beyond Earth are traveling even faster. Re-entering the atmosphere generates enormous amounts of energy in the form of heat. This is because the air molecules around the spacecraft's leading edge are compressed in what's known as a compression shock and split apart, releasing free electrons in the process. This creates a meltingly hot, electrically charged gas known as a plasma, which envelops the spacecraft throughout the early stages of its descent for several minutes, which causes two major problems. First, with temperatures that can exceed 2,000 degrees Celsius, the plasma places considerable stress on the material of the spacecraft. Currently, the heat is mitigated through the use of physical thermal protection systems, which are expensive and add considerable weight to the spacecraft, thus reducing the payload capacity and increasing mission costs. They also create a serious risk of catastrophic failure if a protective layer is damaged. Second, radio waves ricochet off the plasma, which leads to a radio frequency blackout. This makes communication between the craft and ground control impossible. The spacecraft cannot transmit vital data to mission control, who themselves have no means to intervene in case of an emergency, either via radio instructions or remote control. If we want to make space missions both safer and more economically feasible, we need a system that solves these two problems in a way that is cheaper, lighter, and safer. And MEESST promises to do just that.